We're still looking at angles today, but now we're going to look at angles in a different measure. This measure is called radians. You can see the technical definition of a radian, as well as what a radian approximately equals in degrees. So 1 radian is just shy of 60 degrees, so be very careful when you're working with radians. 1 is not the same as 1 degree. The other thing to note when you're talking about angles of rotation in radian is that if there is no label, it's assumed to be radian. You must use that degree symbol when you mean angles in degrees, and you don't label your angles when it's in radians. To convert between radians and degrees, use the fact that half of a circle is 180 degrees, or pi radians. So in our formula here, R is radians, and D is the angle measure in degrees. What I do, instead of trying to memorize these formulas, is I set it up so that the units I want to cancel are divided by each other, and the units I want left are in the numerators. So if I know the degree measure, I will divide by degrees so they cancel, leaving me with my answer in radians. If I know the radian measure, I will divide by pi radians so that my answer is left in degrees. And then we have a circle set up here with some common conversions between degrees and radians that you will want to become familiar with. Our essential question today is all about radians and trying to compare something that's new to us to something we are already familiar with, which would be angle measures in degrees. First, we'll start with conversions, and we'll do this without a calculator. You may be asked to do this on a non-calculator portion of a test in your future. Starting off, I have the angle measure in degrees, so that means I want my degrees to cancel. So I will put 180 degrees in the denominator, so those units cancel, and 180 degrees equals pi radians. That's the units I want my answer in. Simplifying 120 over 80, the zeros cancel, dividing by 10, and 12 over 18, those are both divisible by 6. 12 divided by 6 is 2, so I have 2 pi in the numerator, and 18 divided by 6 is 3. So 120 degrees is equal to 2 pi over 3 radians. Negative 90 degrees, again, I want my degrees to cancel, so 180 degrees goes in the denominator, and I want radians left in the numerator. 90 over 180 simplifies to 1/2. So I have negative pi over 2 radians. Next, I'm going to convert from radians to degrees. So I want my radians to cancel, and I want my degrees left on my answer. Obviously, those pi's cancel. 180 divided by 6 is 30. So pi over 6 radians equals 30 degrees. And finally, negative 3 pi over 4. Again, I want those radians to cancel, and I want my units left in degrees, so that will go in the numerator. The pi's cancel. 180 divided by 4 is 45. And 3 times 45 is 135 degrees. So negative 3 pi over 4 is equal to negative 135 degrees. Next comes the tricky part, trying to figure out how to sketch an angle of rotation in radians. What is very important for working in radians is understanding your fractions. Over at 180 degrees, we would have pi radians. Because our angle is in negatives, I am going to label my circle in negatives as well. Typically, up at 90 degrees, we would have pi over 2, but we're rotating in a negative direction. So negative 90 degrees is negative pi over 2. Continuing to rotate, we would have negative 3 pi over 2, and a full rotation would be negative 2 pi. So it's important to understand how pi over 3 relates to pi over 2. Is it larger or smaller? Think about your fractions. Is 1/3 larger or smaller than 1/2? If you take something and you cut it into halves versus thirds, a half is larger than a third. Another way to think about it is this is a full pi. We have 1/3 of that. So think about taking that half rotation and splitting it into thirds. We would end up shy of pi over 2. So that is a negative pi over 3 angle of rotation. Here's a slightly easier one. So 1, it's positive. We'll be rotating in a counterclockwise direction, which will make it slightly easier on us. And we're splitting pi into fourths, which you split it in half, and then you split it in half again. So over here would be pi over 4. So rotating halfway through that second quadrant would be 3 pi over 4. Even easier, pi over 2, which is half of pi. That would be a 90-degree angle of rotation. I just realized I failed to sketch in the initial side on all of these. Remember, we're sketching them in standard position, so the initial side is always that positive x-axis. And another challenging one, negative 7 pi over 6. We're over here at negative pi. 7 over 6 is larger than 1. So we know we're rotating past pi, and a sixth is not a large fraction. So we're rotating 1/6 past pi to give us our negative 7 pi over 6 angle of rotation. Even more fun, complementary and supplementary in radians. Complementary in degrees is 90 degrees, which is equal to pi over 2 radians. So we'll subtract off our pi over 4 radians, and as we all know, in order to subtract fractions, we need a common denominator. So I'm going to multiply that pi over 2 by 2 over 2 in order to get a common denominator with my pi over 4, and we get a complementary angle of pi over 4 radians. Supplementary angles are 180 degrees, which is pi radians, subtracting off that pi over 4, and getting a common denominator. I'll multiply my pi by 4 over 4. Subtracting off that pi over 4, I get a supplementary angle of 3 pi over 4 radians. 2 pi over 3 for a complementary angle. I would take pi over 2, or 90 degrees, minus my angle of rotation. My common denominator is 6. So I'll multiply my pi over 2 by 3 over 3, and I'll multiply my 2 pi over 3 by 2 over 2. Subtracting, I get negative pi over 6. However, similar to degrees and how you learned in geometry, if an angle is larger than 90 degrees, it does not have a complement. Same in radians. This angle is larger than pi over 2 radians, so there is no complement. Finding a supplement, we take pi minus 2 pi over 3, multiplying pi by 3 over 3, and subtracting, I get a supplement of pi over 3 radians. My last one is simply 1.6 radians. Since this is not in terms of pi, we will go ahead and use a calculator for this one. So my complement would be pi over 2 minus 1.6. Use the pi button on your calculator. When we're talking pi radians, it is approximately 3.14. I got about negative 0.029. So once again, this is larger than pi over 2 radians, so there is no complement. For my supplement, I will take pi minus 1.6, again, using that pi button on your calculator, and I got about 1.542 radians for my supplement. And finally, coterminal angles. This is where we either add a full rotation or subtract a full rotation. For 11 pi over 6, if I add 2 pi, I will get a coterminal angle. Finding a common denominator, multiplying my 2 pi by 6 over 6, I get 12 pi over 6 for a coterminal angle of 23 pi over 6 for a positive coterminal angle. Now I will subtract those. Since I already found a common denominator, I will start with that. 11 pi over 6 minus 12 pi over 6 would give me a negative pi over 6 coterminal angle. Taking negative 5 pi over 4 and adding on 2 pi to get a positive coterminal angle. Finding a common denominator, I will multiply 2 pi by 4 over 4 to give me 8 pi over 4. So my positive coterminal angle is 3 pi over 4. Subtracting that 2 pi, or 8 pi over 4, to get a negative coterminal angle, I have negative 13 pi over 4. One thing to keep in mind about coterminal angles is I'm showing you the next coterminal angle. You can add on the 2 pi, or the 360 degrees if you're in degrees, as many times as you need to in order to find a positive or a negative coterminal angle. If you started, and I'll use degrees because you're more comfortable with that, if you started with a 400-degree angle and you subtracted 360 degrees, you would not get a negative coterminal angle. So you would have to subtract another 360 degrees in order to answer the question. You have 3 U-try questions. I understand radians are new, which makes them challenging. Please attempt these to the best of your ability from what you got from this video, and come to class with any questions you have that we need to answer together.